Question number 2. For any two complex numbers z1 and z2, for any two complex number z1 and z2 with the condition modulus z1 equal to modulus z equal to 1 and z1 z2 is not equal to minus 1, show that z1 plus z2 by 1 plus z1 z2 is a real number. That means only real part will exist. A real number we should prove. Any two complex number z1 and z2, modulus of z1 and z2 will be equal to 1 and product of z1 and z2 not equal to minus 1. We should prove or show that z1 plus z2 by 1 plus z1 z2 is a real number. So okay, now let z equal to the total complex number. Let z equal to z1 plus z2 by 1 plus z1 z2. Now apply conjugate. Z bar equal to z1 plus z2 whole bar divided by 1 plus z1 z2 whole bar. We can apply totally conjugate, then we can split the conjugate. Directly I have written here. Now by the property we can split the conjugate as z1 bar plus z2 bar divided by 1 plus z1 bar into z2 bar. We can separate the conjugates. Here given modulus z1 equal to 1 and z1 z2 is not equal to minus 1. We have a property z bar equal to modulus z square. So z1 bar equal to modulus z1 square. Modulus z1 is 1. So z1 bar equal to 1. So z1 bar will be equal to 1 by z1. Similarly we can write z2 bar equal to 1 by z2 because for z2 also it is equal to 1. Applying the same condition will derive z2 bar equal to 1 by z2. So substituting 1 by z1 and 1 by z2 for z1 and z2 here will get 1 by z1 plus 1 by z2 divided by 1 plus 1 by z1 into 1 by z2. Now can simplify this, which is equal to, by simplifying taking LCM, z1 plus z2 divided by z1 z2 whole divided by, just cross multiply z2 plus z1 by z2 z2 or z1 plus z2 by z1 z2. Here taking LCM, z1 z2 plus 1 by z1 z2. We can eliminate the denominator here, which will implies z1 plus z2 by z1 z2 plus 1. Look at the value of z, both are equal, z1 plus z2 by 1 plus z2 z2, that is equal to z. We have started z bar, we end at z, which implies z bar equal to z. So by the property, when z and z bar are equal, when z equal to z bar, when the given complex number z is real, so which implies z is real. Z equal to z bar, the complex number z is real. Question number 3. Which one of the points 10 minus 8i, 11 plus 6i is closest to 1 plus i, is closer to 1 plus i? We should find 10 minus 8i or 11 plus 6i, which is closest to 1 plus i. So how can we prove this? To prove this, just calculate the distance between the points 10 minus 8i and 1 plus i, then 11 plus 6i and 1 plus i. The minimum value is maintaining the closest distance. So by finding its distance, to calculate the distance we have distance formula between two complex number, modulus of z1 minus z2, that is equal to root of x1 minus x2 whole square plus y1 minus y2 whole square. Here x1, x2 are real and real part of the first and second complex number. Y1, y2 are imaginary parts of the first and second complex number. So now finding distance between 10 minus 8i to 1 plus I first. Distance from 1 plus I to distance from 1 plus I to 10 minus 8i, that is equal to modulus of 10 minus 8i minus of 1 plus I. It's equal to root of, you can simplify, then you can apply modulus. 10 minus 1 is 9, minus 8i minus I is minus 9i. Calculating its distance, root of 9 square 81 plus 9 square 81, because square root of sum of the squares of real and imaginary part. Real part 9, 9 square, imaginary part minus 9 square plus 81. Simplifying this, we will get root of 162. Here, then the distance from 11 plus 6i to 1 plus I. Now, distance from 1 plus I to 11 plus 6i, which is equal to modulus of 11 plus 6i minus of 1 plus I. 11 minus 1 is 10, 6i minus I is plus 5i, that is equal to root of 10 square 100 plus 5 square 25 equal root of 125. Comparing these two values, 162 is greater than 120, root 125. Root 162 is greater than root 125. So, the 11 plus 6i is closest to 1 plus I. Therefore, 11 plus 6i is closest to 1 plus I. Very simple. Just calculating distance between 10 minus 8i to 1 plus I and 11 plus 6i to 1 plus I. Comparing the results, this is lesser than the previous one. So it maintains minimum distance between with 1 plus I. So 11 plus 6i is closest to 1 plus I. Question number 4. Modulus of z equal to 3. Show that modulus of z plus 6 minus 8i greater than or equal to 7, less than or equal to 13. Here z1 is a complex number. Then 6 minus 8i is another complex number. Then modulus of z value is given as 3. We should prove that, show that this modulus value is greater than or equal to 7, less than or equal to 13. We have property, a combined form of two different properties. This one, in general, we have modulus of z1 plus z2 is less than or equal to modulus z1 plus modulus z2, and it is greater than or equal to modulus of modulus z1 minus modulus z2. Now here z1 is z and z2 is 6 minus 8i. Comparing these two, z1, for z1 we have z, for z2 we have 6 minus 8i. Substituting in this formula, modulus of z1 modulus z minus modulus of z2 modulus of 6 plus minus 8i less than or equal to modulus of z plus 6 minus 8i, that is less than or equal to modulus of z1 modulus z plus modulus of z2 6 minus 8i. Here modulus z is given as 3. So modulus of 3 minus modulus of this one is root of 36 plus 8 square 64 modulus less than or equal to modulus of z plus 6 minus 8i and less than or equal to modulus of z is 3 given plus root of 36 plus 64 here. Now simplify this. 3 minus root of 100 is 10. So 3 minus 10 modulus of 3 minus 10 less than or equal to modulus of z plus 6 minus 8i less than or equal to 3 plus root of 100 is 10. Root of 36 plus 64, root 100, that is equal to 10. So 10 added here and there. Here minus we have, so 3 minus 10. Here plus we have, so 3 plus 10. So simplifying this, modulus of minus 7 less than or equal to modulus of z plus 6 minus 8i less than or equal to 13. So modulus of minus 7 is 7 less than or equal to modulus of z minus 8i less than or equal to 13. Thus we have proved. Here z1 is z and z2 is 6 minus 8i. z1 is z, z2 is 6 minus 8i. Substituting in this formula for z1 is z and z2 6 minus 8i, we have for z1 is z, for z2 6 minus 8i. In the left side also for z1 is z, for z2 6 minus 8i. And then find substitute modulus at equal to 3 given and find its modulus. Here also substitute modulus at equal to 3 and find its modulus. Then simplify, you will get the answer. It's very important. For z1 we have z and for z2 we have 6 minus 8i. Just substituting these two results and simplify, you will get the answer. Question number 5. Given modulus z equal to 1, then show that modulus of z square minus 3 is greater than or equal to 2 and less than or equal to 4. This is same as previous problem. We have formula in general. Modulus of z1 plus z2 is greater than or equal to modulus z1 minus modulus z2 modulus and less than or equal to modulus z1 plus modulus z2. So this is modulus z1, this one is z1, another one is z2. Substituting here, modulus of z1 is modulus z square minus modulus z2 is modulus 3 less than or equal to z square minus 3 less than or equal to modulus z square plus modulus of minus 3. Modulus z is 1, so modulus z square 1 minus modulus of minus 3 is 3 greater than or equal to less than or equal to modulus z square minus 3 less than or equal to modulus z square means 1 square 1 plus of modulus of minus 3 plus 3. Here modulus of 1 minus 3 minus 2 less than or equal to modulus z square minus 3 less than or equal to 1 plus 3, 4. Modulus of minus 2 is 2 less than or equal to modulus of z square minus 3 less than or equal to 4. That's how you have derived the result.